Hi, good day, everybody. My name is Isaac Koche from the Center for Coastal Management at the University of Cape Coast in Ghana. And as part of the USAID Women, Shellfishers and Food Security Project, I'm presenting on research we have done, on an in-depth research actually, on an analysis of oyster shell fisheries and associated biophysical parameters of 6 estuaries in Ghana and the Gambia. The oyster fishery is actually a triangulation between the environment, including the water and mangroves, which support the oysters and which are exploited by humans, essentially the women. So on this triangulation, our assessments covered the water quality, including seasonal dynamics, and then the nutrient levels, and then the oyster growth, the condition of the oysters, the oyster meat safety for consumption, and then we also examined some management systems in place at each location. The study was carried out as I said, in Ghana, Gambia. In Ghana, we worked in the Western, Central, and Greater Accra regions, looking at the Wind Estuary in the Western, Nakwa in Central, and then the Densu in the Greater Accra. And in Gambia, we worked in Alain, Tambe, and Bullock. So it's a 12-month study still ongoing to end in March 2022, and we are looking at the physicochemical parameters, essentially temperature, salinity, dissolved oxygen, pH, and turbidity, the nutrients. We are looking at nitrate, phosphate levels in the water, the oyster size. We are looking at the shell length, shell height and weight, the condition of the oysters. We were working on wet and dry meat weight. And then the contaminants, we are working on heavy metals, and also conducting interviews on the management modalities in place. Now, to share some preliminary results, and starting from the salinity, looking at the salinity of the Gambian waters, you could see that they are a bit more marine and more stable than the Ghanaian waters. Gambian waters recording about 40 parts per thousand, and with the coming of the rains is dropping gradually. But compared to the Ghanaian waters experience more fluctuations, and this have some implications for the oyster population, as the oysters are brackish water to marine waters inhabitants. Next is the dissolved oxygen, and you can also see that for some time between April and May, before the rains, there is much higher oxygen in the Gambian waters than it is in the Ghana waters. Though with the onset of the rains now, both Ghana and Gambian oxygen levels have dropped, but by and large, before the rains, Gambia is higher. The next is turbidity, which is also very, very important because oysters are filter feeders, and the more turbid the water is, the more unfavorable the environment will be for the oysters. And as you can also see, during the rains, we record very high turbidity in Ghana, especially in the wind estuaries. And in the wind, there are some alluvial gold mining activities going on upstream. So during the rain, this is common of some waters in Ghana. Aside the rain, we have the Pra, we have the Ankobra, all of which experience this. That there's very high runoff, which washes these sediments to silt the water. In fact, we have some data gaps actually, which we are still trying to fill. But you can see, by and large, the Gambian waters have significantly low turbidity levels than the Ghana waters. With the nitrates, the optimum level for primary productivity is 1 milligram per liter, and as you can see, there's quite high nitrate levels in the waters in both Ghana and Gambia, which means some primary productivity should be occurring and good for the oysters. And phosphate levels as well. You can see a higher concentration of phosphate in the waters. And these are showing more in the urban areas. So Tambi is more urbanized in Gambia. Densu is urbanized in Ghana, is actually at the heart of Accra. And when is also urbanized in the secondary Takoradi metropolis of Ghana. So these are urbanized places, and more phosphate are perhaps leaching into the water from some agriculture or other industrial activities into the water. So up here, the blue is the concentration, and then this is normal reference water without the phosphate, and so you can see the extent of change deeper. Now with the oyster sizes, looking at the shell heights, you can see that Bullock had consistently bigger oysters with a median size around 9 centimeters throughout March, April, May, before the sizes dropped in June. And Bullock had implemented a closed season for nearly a year. There is a management regime in place, and so when we started the work in March, you could see the oysters were big, but then the May-June coincided with the Ramadan, during which they opened the season for harvesting, so the sizes dropped. And if you compare the Densu oysters to, you can see Densu had the biggest oysters in Ghana, and similarly Densu also has a co-management policy in place within which the oyster fishery is closed, and then later is opened from June, July going. So you can see oyster has the biggest, Densu has the biggest oysters in Ghana, and Nakwa has the smallest, consistently smallest oysters, because there is no management plan in place, and it's just open access, so there's extensive fishing pressure on the oysters. Linking the data also to the condition, you can see Bullock oysters actually recorded the best condition in March when the research was started, and then later as they harvested into the Ramadan, the conditions dropped in April, May going. But Alain comes next to Bullock, and for Alain, the oysters were closed from harvesting in the whole of 2021. They said they are not harvesting, so you can see Alain oysters have very good condition coming into May, June, and going forward. We are yet to add the data for July, August, and ongoing. So quite some good management practices are in place in Gambia, and then also for Densu in Ghana, while in Win and Napa, there's no management in place. Now, to expand on the heavy metals, and starting with Mercury. In the first quarter in March, you could see that the permissible limits are introduced, are indicated with the dotted lines, and this is for the water, and this is for the oyster meat. And you can see that in March, in the first quarter, the mercury levels were low, but then in June, mercury levels were extremely high in the waters of the Ernest estuary. And once again, mercury is used for processing of alluvial gold. So it could be that in June, in the Ernest estuary, during a lot of the mercury was washed into the water as a result of the rains. But if you look at it in the oyster flesh, they are all significantly low across all sites. Arsenic also, in the first quarter, the levels in the waters were around the permissible limit, except in Nakwa in Ghana, and then in the second quarter in June, it became quite high in Densu, and especially in Wen, very high. Perhaps the rains may also have contributed to this, as Ghana experiences the rainy season in June. So perhaps the rain may have contributed to this. But if you look at the levels in the oyster flesh, you could see that they are still below permissible limits in the flesh. And then you look at cadmium. The levels were very high in the first quarter, but were reduced or much lower in the second quarter, with most locations around the permissible limits. And this seems to relate also with what is in the flesh. You can see that in the first quarter was a bit higher in the flesh, and then in the second quarter is reduced. We are yet to add the data for Ghana. Chromium also followed a similar trend, being a bit high in some water bodies in the first quarter, and then very low in the second quarter, far below the permissible limits in the water, and then also in the flesh, except in when the level was so high above the permissible limit in the first quarter. And lead levels were all very low above permissible limits in the water, except at rain once again, where it was very high, though above the permissible limit. But in the flesh, all the sites had quite significant levels of lead in the first and second quarter in a number of water bodies, which were a little above the permissible limit. So with the management systems in place, as summarized here, you can see that in the three Gambian water bodies, there are some management modalities in place, either Women's Shellfishers Association or Village Development Committee working with the ministry to implement some closed seasons and restricting mangrove harvest, which may have contributed to the bigger and better condition of oysters found in places like Bullock. And then in the Wen estuary, Nakwa, there is no management also in place, which may have contributed to perhaps the smaller oysters found and the poor water quality in the Hen. And Densu in Ghana, as it is in Gambia, also has some management modalities in place, hence the bigger oysters found in the Densu estuary. Thank you very much for your attention.